Hi everyone, welcome to Math Prowess. Before us here, we have a Russian Math Olympiad question. The question reads, x to the power of 3 minus y to the power of 3 equal to xy plus 61. They say where x and y are positive integers. So here we have to find the positive integers of x and y that satisfy this expression we have in here. So if you're new here, this is Math Prowess. If you're not subscribed, subscribe so that you get notified whenever we release amazing videos, because at Math Prowess, we release powerful videos all the time. Some math tricks that enable you to beat all competitive exams in mathematics. Right, so let's take our solution from here. So we have solution. All right, now from this question, we look carefully. If you look at the question very well, here we are having the powers are the same and we have a minus sign here. Let's come to the right hand side. We are having the product of the quantity we have on the left hand side from here now on the right. Okay, now we're also having an addition of 61. So what does that imply? Since both of them have the same powers, so it also means that x is greater than y. And again, if you look at this, we are saying the product of this plus this. So it also means that your x and y, let's put it, x and y are also greater than 0. So if x is greater than y and x and y are greater than 0, so what are the positive integers of x and y that will satisfy this expression? So let's go into solving. I'm going to take you step by step on how to solve this now. Now, if you look at the left-hand side of the expression of the equation, which is this, we have an algebraic identity for this, right? So remember the algebraic identity, which says that if you have your a to the power of 3, then minus your b to the power of 3, this is equal to bracket a minus b, close bracket, the bracket, your a squared plus your ab plus your b squared, close bracket. You remember this algebraic identity? Yes. All right, so this is what we're going to use here now. In other words, we can rewrite the left-hand side in this format because it's of this kind. So rewriting the left-hand side, we're going to come up with this. So this now implies that bracket x minus y, close bracket, bracket your x squared plus xy plus y squared, close bracket, everything equals to xy plus 61. This has not really changed anything. Now look at this again now. If you check this, we can add this and this together. So if we bring that together, we're going to come up with our x minus y, close bracket, bracket, in fact, let's use the square bracket, the bracket x squared plus y squared, close bracket, plus our x, y, okay, square bracket close, everything equal to x, y plus 61. I want to use this entity here to open up this square bracket. So if I do that, this will give us bracket open x minus y, close bracket, bracket x squared plus y squared, close bracket, plus our x minus y, close bracket, into our x, y, close bracket, everything equal to x, y plus 61. You now discover that we have this here, we have this here. So what we do next here now, it is easy. Look at what I did here. It's crazy. All right. We are having a quantity here. We are having this same quantity here. So I want to, and we have this number here. So this is standing as a coefficient. So I want to compare coefficient now. So I want to take this quantity out and compare the coefficient. So the coefficient here is 1 and the coefficient here is what? X minus 1. So from here I can establish a new equation from this original equation. So this now implies that our x minus y is equal to 1. In fact, let's give this equation star. Then we are now left with this equal to 61. So we are now left with our x to the power of 2 plus y to the power of 2 equal to 61. Easy. Now from equation star, we can make y the subject of the formula. Okay, so let's take here from equation star. Okay, so let's make y the subject of the formula. So making y the subject of the formula will automatically means that y is equal to x minus 1. Again, let's give this equation star star. So if we have this as equation star star, we do something special again. We now put the whole of equation star star into this expression we have here, which is easy. So wherever we see y, let's put this x minus 1 into it. So this equation now implies that x to the power of 2 plus bracket your x minus 1 close bracket all to the power of 2 equal to 61. All we need to do is to open up this here. So if we open this will give us x to the power of 2 plus x squared minus 2x plus 1 equals to 61. We are having 2 of this now. So this will give us 2 to the power of 2x to the power of 2, then minus 2x. Then if we move this to this side, this will give us plus 61 minus 61, please. Minus 61 plus 1. This is equal to 0. So this will now end up giving us 2x squared minus 2x minus 60 equal to 0. Now you can discover or you see that something is common to these expression 2 can divide through. So if we use 2 to divide everything here, we are going to be left out with x squared minus x minus 30 equal to 0. So what do we do here now? This is a quadratic equation, and we can use the factorization method to simplify this down. So how do we use factorization method? We bring out the constant term here and look for all the factors of 30. Okay, they are plus minus. Then we look for two numbers out of all the factors that we multiply together to give us minus 30, add together to give us minus 1. Without much waste of time, the two factors will give us plus 5 minus 6. So if we have plus 5 and minus 6, let's do the arithmetic before we forge ahead. Plus 5 times minus 6 will give us minus 30. Plus 5 minus 6 will give us minus 1. So we go ahead to substitute plus 5x and minus 6x into this place of minus x. So this might give us x to the power of 2 plus 5x minus 6x minus 30, everything equal to 0. Any confusion so far? No. So we cannot put this in bracket and factor terms that are common to each bracket. The first bracket here, what is common is just x. So we now have this to be x rather. So we have x, okay, bracket here. We'll be left with x plus, here we'll be left with 5. Then minus, what is common here is 6. So we have 6. Here we're left with x. Minus times minus will give us plus. 6 into 30 will give us 5. Close bracket is equal to 0. So what do you see out here now? You discover that what you have inside the two brackets are the same. So what we do, we take this x and this is outside and this one of the x. So we now have this to be x minus 6, the bracket x plus 5, everything equal to 0. Are we learning something here? Yes. At this point, we apply what is called the zero product rule. We say that we equate this to 0, equate this to 0. So when I have this to be x minus 6 equal to 0, or your x plus 5 equal to 0. So we're going to have this to be x is equal to 6, or our x is equal to minus 5. So from this condition here, our s cannot be minus 5 here. So the only accepted value of x is 6. So we cannot say therefore our x is equal to 6. All right, so we've gotten the value for our x. So how do we get the value for our y? Now recall equation star or equation star star. Look at equation star star. So all we just need to do is to substitute for the value of x and get our y from here. Now from our equation star star, we can now just put the value of x in here. So we have here 6 minus 1. And 6 minus 1 will give us what? 5. So therefore our y is equals to 5. Okay. All right. So now we've gotten the value of x and y. So let's just say here we have here x comma y will now be equal to your 6 comma 5. Okay. So these are the the answer to our math Olympiad. But we can run a check for the answer to know if they are correct or not. So let's do a quick check on our answers. So we have here check. Our question, our original equation is x to the power of 3 minus y to the power of 3 equal to x, y plus 61. Remember? So first we're going to have 6 to the power of 3 minus 5 to the power of 3, which is equals to your 6 times 5 plus 61. Okay. Yes. So what is 6 to the power of 3? That will give us 216, right? Yeah, I think so. 216, yeah. So we have 216 minus 5 to the power of 3. That will give us 125. So 125 equal to, and 6 times 5 will give us 30, okay, plus 61. All right, so we can now subtract this from this. This from 5 from 6 will give us 1. 2 from 1 cannot borrow 1 from here. That gives us 11. Then 2 from 11 will give us 9. Then 1 from 1 will give us a 0. So this is equal to, if we add 30 to 61, this will give us 1. Then 3 plus 6 will give us 9. So we're having 91 equal to 91. So that shows that the answers x equal to 6 and y equal to 5 satisfy the original equation here, okay, which is this. S to the power of 3 minus y to the power of 3 equal to xy plus 61. All right, so this is the procedure, the steps you can use in solving this math Olympiad, this Russian math Olympiad question. All right, okay, so if you have any question with regard to the steps, to the procedure applied in solving this wonderful Russian math Olympiad question, then drop it in the comment section and see everything is clear to you. There also drop a comment. It could be thanks math prowess, and also you have a better way of solving this challenge. Do not hesitate to drop it in the comment section. Remember, we all here at Math Prowess, we love you for being them all the time. Bye for now.